Hello. When we open the slide software interface page will look like this. The various options are explained in the stability of slope video. Under the project settings, we need to change the groundwater method. By changing it to steady state FEA will enable us to do the seepage analysis. By changing the groundwater method, we can see two tabs at the bottom. That is, one is for slope stability. Other is steady state groundwater. The advantage of this is we can do seepage analysis separately. Further, if we want to do slope stability, it can read the seepage results and accordingly it does the stability calculations. Now, we have to create external boundary. In all the rock science softwares, external boundary creation is important and any changes or additions to geometry will be done within the external boundary. According to our geometry, we can enter coordinates and prepare an external boundary as shown here. Once we create the geometry, we change the tabs to steady state groundwater. In this tab, we can define hydraulic properties. Mesh can be defined here also. Once we create the geometry, we change the tabs to steady state groundwater. In this tab, we can define hydraulic properties. Mesh can be defined here also. Once the properties are created and assigned, we need to develop the mesh. When mesh is completed, we can see the mesh applied. But we can notice here the blue color question marks along the boundary. These are nothing but one of the hydraulic boundary condition. Now we have to develop or model the boundary conditions. Here we can see there are different types of boundary conditions. Upstream side we will have to give total head corresponding to reservoir level. For this case, 26 meters is being given as total head. While the downstream side there won't be any water. So we can give 0 head. But we do not know the seepage through the dam. Because of this we cannot give 0 boundary condition. That is how this question mark boundary is helpful. Whenever there is seepage or pressure above atmospheric, it removes the seepage. That means this boundary represents filter. This means it collects the seepage. Now we have to run or compute the file. After computing, we will see the results. This interface shows the results page. Here, we can check different parameters. Top red line shows the phreatic line. There are so many options. We can change the color code. We can change the contour values and so on. There is seepage coming from the downstream slope. We do not know the quantity. To know the discharge quantity, we have to add discharge section wherever we have to find the seepage quantity. We can see the discharge quantity the downstream slope. The seepage coming at the downstream slope may create issues. So to avoid this, let us repeat the same problem with creation of rock toe or filter kind of zone at the downstream, and let us see how the phreatic line changes. As we can see here, by addition of rock toe with permeability value is more than the dam material to act as seepage collection of filter, we can see the change in phreatic line. Now the water surface is not touching the downstream slope. This way we can analyze the requirement of filter or rock toe.